Welcome to the Explainer. Today, we're cracking open the System Architect's toolbox to really get a handle on the fundamental trade-offs you have to make when building software that's meant to scale, like really scale.
So, how do you build an app for millions and millions of users? Well, let's just get this out of the way right now. There is no single perfect answer. It's really about making a series of smart, deliberate choices and understanding that every single choice comes with its own set of pros and its own set of cons. So here's how we're going to break it down. We'll start with the big picture challenge. Then we'll dive into the tools architects use for everything from managing traffic and structuring their apps to handling how data moves around. And to make it all real, we're going to cap it off with an amazing case study from Google to see how these ideas work at the absolute highest level.
All right, first things first, you have to understand that system design is a constant balancing act. Every single choice you make to gain something, maybe it's raw performance, well, it's probably going to cost you something else, like simplicity or speed of development. There are no perfect solutions here, just different choices with very different outcomes.
This quote just nails it, doesn't it? It all comes down to your specific problem. The right choice for Netflix, with its massive streaming demands, would be complete and total overkill for a small e-commerce startup. Context, as they say, is everything. Okay, let's get practical and grab the first tool from our toolkit. So, picture this. Your service is a huge hit, and now it's getting slammed with requests. How do you protect it without just turning it off? Well, you've got two main levers you can pull: throttling and rate limiting. Throttling is basically like a traffic cop during rush hour. It's not about stopping cars, it's about managing the flow. The idea is to weather a sudden storm of activity and keep the service running for everyone, even if things get a little bit slower for a while. Rate limiting, though, that's a totally different beast. Think of it more like a strict bouncer at an exclusive club. It sets a hard, non-negotiable cap. You get, say, 100 requests per minute. You hit 101? Sorry, you're blocked. You'll have to wait. This is all about preventing abuse and protecting your resources. And this is where you really see the trade-off in black and white. It all boils down to this. Throttling prioritizes service availability. It slows things down to keep the lights on for everybody. Rate limiting, on the other hand, prioritizes resource protection. It puts up a wall to stop any one user from sinking the whole ship.
All right, tool number 2, and this is a big one. It's about the fundamental structure of your entire application. Are you going to build it as one single massive unit, or are you going to break it up into a bunch of smaller, independent pieces?
This analogy just explains it perfectly. A monolith is like one giant restaurant kitchen. Everything's made in the same place, it's all connected, all part of one big operation. Microservices, though, are more like a food court. You've got the pizza place, the taco stand, the noodle bar. They all operate on their own, but together, they make up the whole experience. So why would you ever pick the giant kitchen? Well, one word: simplicity. When you're just starting out, a monolith is often the way to go because you can build and make changes incredibly fast. Your whole team is in one code base, and you can focus all your energy on what really matters, finding out if you're building something people actually want. But then you have microservices, and this is where things get really interesting at scale. If the payment service gets slammed during a Black Friday sale, you can scale up just that service. If the user recommendation engine goes down for a minute, well, guess what? People can still search for and buy things. It gives you incredible flexibility and resilience when you're dealing with massive complexity. Okay, so you've got all these different services, or maybe just different parts of your monolith. How do they actually talk to each other? When one part of the system needs to send a message to another, does it actively go and hand deliver it, or does it leave it in a mailbox for the other part to come and pick up later? So think of RabbitMQ as a super reliable post office. You give it a message, and it takes on the responsibility of figuring out exactly where it needs to go and actively pushing it to the right recipient. The broker does the heavy lifting of delivery. Kafka, though, has a totally different philosophy. It's not a post office, it's more like a library. Messages get published to different shelves or topics. Then the consumers can come to the library whenever they want, check out the messages they need, and they keep their own bookmark of where they left off. They pull the data on their own schedule. And this difference is absolutely critical. RabbitMQ is fantastic when you need complex routing, like sending a specific task to a specific worker. But Kafka, because it holds onto messages for a while, gives you this durable log of everything that's happened. That makes it perfect for things like real-time data pipelines and analytics, where you might want to replay events. All right, enough theory. Let's see how the pros do it.
We're going to look at a system designed to handle data at a planetary scale, the Google File System, or GFS. And this is a masterclass in designing for very specific trade-offs. Now, the genius of the Google architects is that they started by just accepting their reality, which was a very harsh reality. First, they knew that hardware would always fail. It wasn't an if, it was a when. Second, their files weren't just big, they were enormous. And finally, for what they were doing, getting a huge amount of data moved over time was way more important than getting a tiny bit of data moved instantly. These assumptions drove every single decision they made. And those assumptions led them to this absolutely wild design choice you see right here, a 64 megabyte chunk size. Now, you have to understand that is massive. It's almost unheard of in a normal file system. But why do it? Because when you're dealing with gigantic files, a huge chunk size dramatically cuts down on the chatter. It keeps the clients from constantly bothering the main server, which prevents a huge bottleneck and lets the data flow like a fire hose. And that 64 megabyte chunk size completely dictated how they wrote data. They did something brilliant. They separated the instructions from the actual data. As you can see here, the client pushes that massive chunk of data directly from one server to the next in a chain, almost like a bucket brigade. It's only after all that data is in place that the primary server gives the final, "Okay, write it" command. This keeps the network pipes full and creates an unbelievably efficient system perfectly designed for their specific needs. So, after all that, how do you pick the right tools from the toolkit for your project? Well, the most important thing to remember is that the right choice for today might be the wrong choice for tomorrow. I mean, just look at the giants, Netflix, Uber. You think they started day one with some globally distributed, super complex microservices architecture? No way. They started with a simple monolith that let them get their product out the door and find customers. They only evolved to a more complex system as their scale and their business needs demanded it. And this quote from Paul Graham just sums it all up perfectly. The best architecture isn't some rigid, perfect plan. It's one that solves today's problems really, really well, while still being flexible enough to adapt to whatever crazy challenges tomorrow throws at you. So I'll leave you with this final, crucial question to think about. Are you building and optimizing for the problem you have right now, or are you building for the problem you think you're going to have in the future? The answer to that question will guide every single choice you make.